Evening, Bearcats. I just want to do a little review tonight and introduce one last new concept called an upper and lower bound chart. Again, just one more tool in helping us to graph and identify our x-intercepts. Always when we're graphing higher degree polynomials, the p's and q's that we've learned about will be our starting point, and that's where we'll start, and that's our possible rational roots. So we know if we have any real ones, that's what they'll be. But then we used Descartes' chart, which I'm going to look at again in just a minute, and the lower and upper bound theorem to help us narrow down which choices off of that list that we would use and be most likely to have as real zeros. All right, let's go ahead and start with this particular function. We're going to start with f of x, and we're going to start with 4x cubed minus 3x squared plus 2x minus 1. Let's go ahead and do our p's and q's, so we'll have that list. It would be the factors of 1, so that's the positive and negative factors of 1, which are just 1, over the positive and negative factors of 4, which would 1, 2, and 4. So our list would be equal to the positive and negative 1 over 1, which is 1, or 1/2, or 1/4. So if we have real zeros, then they would be one of these 6 choices. And there's 6 because they're both positive and negative choices. Let's take a look at Descartes' chart and see what it says to us. Remember, we set up our chart, and this is Descartes' chart. And we set that up by setting up how many positive real roots we possibly have, how many negative roots we will have, how many complex imaginary roots we would have, and of course then the total. We know the total by just looking at our polynomial. The total number of roots we're going to have in this particular function is 3. Probably usually have at least 2 rows in our chart, sometimes more. All right, let's take a look at our chart and go through our little process. If all of these x values were positive, then the sign of the term would not change. And this first term is positive 4x cubed, so a positive sign. The second term is negative 3x squared, so it's a negative sign. The third is a positive, and the last is a negative. We're looking for the sign changes. How often do they switch signs? When we go from positive to negative, that would be 1. Negative to positive would be 1, and then positive to negative. So that's 1, 2, 3 sign changes. So we're going to come down here and we're going to write 3 or reduce it by 2, which would make it 1. 3 or 1. All right, then we're going to go through and we're going to figure out what would happen to the negative values. How many negative real roots could we possibly have? So we're going to come down here and we're going to pretend all the x values are a negative number. If I took a negative number and I cubed it, it would be negative. And a negative times a positive 4 would be a negative value. On this one, if we take a negative number and we square it, it becomes positive. But a positive times a negative 3 would make the whole thing negative. If we take a negative number and we multiply it times a positive 2, it's going to become a negative number. And of course, this constant is negative. So how many times does the signs change? We have negative, 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 negative. There are no sign changes, so we have 0, and underneath that we would put a 0. So our possible rational roots just got cut in half. Let's take a look. Let's move across our chart. We have 3 positives, 0 negatives. We have a total of 3, so there would be no complex numbers. Or we have 1 positive and 2 complex numbers to total 3. So take a look at this. We don't have any negatives. Up here, our possibilities were positive and negatives. We just wiped out half our list. So the only real roots we have are going to be positive 1, positive 1/2, or positive 1/4. Positive 1/4. If we have more than 1, if we try synthetically dividing by 1, we would get, and got a 0, then we would try synthetically by 1/2. If we get another 0, then we could assume that 1/4 was also going to be one of our zeros, one of our rational roots. If we only get 1 and the other 2 don't work, then the last 2 would be irrational, or not irrational, but complex imaginary. The issue is it doesn't matter. Since it's a third degree polynomial, if we find 1 root, and it's got to be one of those positive values, once we find 1, we'll have a quadratic and we would solve it differently. I'm not going to go through solve the quadratic right now, and I'm not going to do the synthetic division right now, but I did want you to go back over the chart and what it means to us in terms of narrowing down our list over here. All right, let's try one more Descartes chart. All right, let's try this function. We have 3x squared plus 2x squared plus x plus 3. Let's take a look at our p's and q's. So it's our positive and negative factors of 3, which would be 1 and 3, over the positive and negative factors of 3, which is 1 and 3. So this is going to give us positive or negative 1 over 1, which is 1, 3 over 1, which is 3, 1 over 3, which is 1/3, and 3 over 3, which is 1, and we already have that. So we have positive and negative 1, 3, or 1/3. That means we have 6 possible choices for roots. Let's try our Descartes chart to see what happens and see if we can eliminate or focus in on where we would start synthetically dividing. So let's go back and do that again. Oops. So we're going to start with our positive, our negative, our complex, imaginary, and our total. All right, well, we know our total is going, that's be a 3, sorry. We know our total is going to be 3. And now let's do positives. This whole term, if all the x's were positive, this term is positive, this term is positive, this term is positive, this is positive. No sign changes, so we'd have 0, and we would put 0 in the second column. So there are no positives. So this time, just like before, we just cut out half our list. So our list now took all the positives out, so it's going to be a -1, a -3, or a -1/3. Let's try the negatives. If I put in my negative values for x, negative cubed is negative times a positive 3 would be negative. Negative squared is positive times a positive 2 would be positive. Negative would be negative, and then a positive 3. So you have 1, 2, 3 sign changes. So you'd have 3, and then reduce it by 2, which would be 1. So you could have 0, 3, and 0, or you'd have 0, 1, and 2 as our chart. And it looks like if we have real rational roots, and we would have to have 1, which would be negative. You always have to have 1 if you're going to have complex. Complex always comes in conjugate pairs. And of course we need 3 roots total. All right, so that takes care of Descartes' chart. All right, the last thing we're going to learn, so the last new thing for the unit, is something called the lower and upper bounds chart. This is very helpful in helping us to know at what point to the right or the positive direction, what point to the negative direction do we stop having x-intercepts? In other words, at what point does the graph on the right side continue up or down forever and never cross the x-axis again? Or to the left, that it moves up or down forever and never crosses the x-axis again? That means any possible roots after that particular value we would not have. All right, let's first go ahead and do our p's and q's again. There's our p and our q, of course. So it'd be the positive and negative factors of 8, which are 1, 2, 4, and 8, over the positive and negative factors of 2, which is 1 and 2. So we have positive or negative 1, 2, 4, and 8, and then 1/2. 2/2 is 1, 4/2 is 2, and 8/2 is 4. So we've already covered those. So it would be these 1, 2, 3, 4, 5, 10 choices, because they'd both be positive or negative. Do you want to go ahead? We could look at the the Descartes chart, but we're not going to do that. We're going to work on this lower and upper bound. I'm going to erase this right here for just a minute so I have a little bit more room. So hold on just a second. All right, our lower and upper bound chart is basically synthetic division, and it's really the synthetic division we've been doing. It's actually the same form that I use most of the time that we've been using in class. So it's all just continuous. We're not making separate little charts, except that we don't really go off the list. We actually go just sequential order, starting at 0. So we're going to start at 0 in just a minute. The first thing we're going to do is fill in our chart at the top for synthetic division. We have a cube, a square, a single, or x, just a plain x, and then we have a constant. So let me go and put my coefficients down. That would be 2, -3, -12, and 8. And of course, we're going to start our chart with 0. That means that if we plugged a 0 in for all the x's, our output would be 8. So our ordered pair over here would be 0, 8. The next thing, we're just going to go in straight order. So for 1, okay, we're going to synthetically divide by 1. Of course, we'd bring down our 2, which is 2. 1 times 2 is 2. 2 and negative 3 would be negative 1. 1 and negative 1 is negative 1. Negative 1 and 12 is negative 13. Negative 13 and 8 would be 5, negative 5. All right, we didn't get a 0, but we have another ordered pair, 1, negative 5. These are all points along our graph, which are going to help us. Let's try 2. Bring down, remember we're using these values to synthetically divide. So bring down the 2. 2 times 2 is 4. 4 and negative 3 is positive 1. 1 times 2 is 2. 2 and negative 12 is negative 10. 2 times 10 is negative, no, 2 times 10, negative 10 is negative 20. Negative 20 and 8 is negative 12. Okay, again, did not give us anything, and that is at 2, negative 12. Notice something in just a minute. To find our upper bound, we're going to get where all of the values are positive, and all the values turn positive. We've reached our upper bound. Let's keep going and try the next number 3. Bring down the 2. 2 times 3 is 6. 6 and negative 3 is 3. 3 times 3 is 9. 9 and 12 is 3. Negative 3. 3 times negative 3 is negative 9. Negative 9 and 8 is negative 1. Okay, we're closer, and we have an ordered pair at 3, negative 1. All right, let's try 4. Bring down the 2. 2 times 4 is 8. 8 and negative 3 is 5. 4 times 5 is 20. 20 and negative 12 is positive 8. All right, and 4 times 8 is 32, and 32 and 8 would be 40. Oh, well, it looks like we might have had a x-intercept in there. We haven't reached our upper bound, but it looks like we actually have reached our upper bound. Our upper bound is all positive. Also, notice something. We crossed over, this ordered pair would be at 440. There's something significant because we moved from a negative to a positive y value. So somewhere between 3 and 4 is an x-intercept. Somewhere between 3 and 4 is an x-intercept. And that's really important. We've reached our upper bound. So this would be 4, would be your upper bound. All right, now we're going to find the lower bound. And the lower bound, these values are not the same. They are the same, but they're alternating signs. So it's positive, negative, or negative, positive. They're alternating signs. So we're going to start over our chart. We're going to start with negative numbers. Since I'm going to use these numbers again, I like to rewrite them. You don't have to, but I just like to rewrite them. So I'm going to do that. Just makes it a little cleaner. And then I'm going to draw my line, and I'm going to start with negatives. So negative 1. Bring down the 2. Negative 1 times 2 is negative 2. Negative 2, negative 3 is negative 5. Negative times negative is a positive 5. 5 and negative 12 is negative 7. And that's positive 7 and a positive 8. That's 15. All right, that's not our upper bound, our lower bound yet because we're not alternating signs. But we did find another ordered pair at negative 1, 15. And all of these ordered pairs you could graph to get your curve, make your curve just a little bit cleaner and a little more accurate. Okay, we still have not reached our lower bound yet. Let's try negative 3. So bring down the 2. Remember, we're using these numbers. It helps sometimes to circle them. So you bring down the 2. 2 times negative 3 is negative 6. Negative 6 and negative 3 is negative 9. Negative 3 times negative 9 is positive 27. Positive 27 and negative 12 would be would be positive 27, negative 12 would be positive 15. Negative 3 times 15 would be a negative 45. Negative 45 and 8. So, negative 3 times negative 3 times 15 is negative 45. Negative 45 and a positive 8 would be negative 37. And we've reached our lower bound. And sometimes I just do LB. And upper bound up here I do UB. We've reached our lower bound because positive, negative, positive, negative. We've reached that alternating pattern that gives our lower bound. We do have a couple ordered pairs here, negative 2, 4. And then negative 3, negative 1, 8, or negative 87. So we have several good points here. We found our upper bound when we start synthetically dividing just in sequential order from 1, and we get all positive numbers. That is our upper bound, and we do the same thing for the negative values, and on the negative values we get an alternating pattern, which lets us know that we've reached our lower bound. And what that means is, if you go over here and you look at your your P's and Q's, your possible rational roots, if the upper bound is 4, then that means that you could try positive numbers 1, 2, and 4. You would never try 8, also 1/2. You would never try 8 because it's out of your upper bound. You know it's not going to work. For your lower bound, you stop at negative 3. So you would try negative 1, negative 2, negative 4, I guess become negative 1/2, and not negative 8. It would be excluded. All right, that's everything I want to teach you about lower and upper bound chart. Tomorrow when you come in, you're going to have 7 problems. I will have those out on your desk. Please do not write on the class copy. I will have 7 problems you will need to write on your own piece of paper, and you're going to have to actually turn it in. You're going to have to turn those papers in, so please write on something that you can turn in. If when you turn your paper in, you write in the top right corner by your name, the top right corner by your name and class period, write Go Bearcats. If you write Go Bearcats, we'll have maybe a little bonus in there for you. All right, have a great night, and like we always say, Go Bearcats!